When next point is design patterns. Design patterns are basically used for the designing of the programs, or we can say models. Design patterns are going to be basically, it is used for the used products or used applications. Already it is going to be present, that models that you'll be going to take, and the solutions are already existing in that, those things that you'll be going to use it in the system. That is the design patterns. Here it is the abstract knowledge of the problem definition, and there is a solution is also existing in that. Okay, then it is going to consist of descriptions about the program, that is the problem definitions, as well as the solution to that. And usually this is going to be reused in the different ways. The execution point that is going to be reused in different models. And basically this pattern, the design patterns, are going to use the object-oriented concepts in that inheritance and polymorphism. The patterns are going to be there and its elements. So the patterns are nothing but the languages which is going to be described in the practices of designing and all the things that it is going to be used. So here is some of the what we can say, the elements are going to be present for the patterns. The name is one part element, so it is a meaningful pattern for the identification. Usually class name, the name is going to be identified and is going to be used. It can be called problem description. So here the what exactly that particular function should do, that it is being mentioned in this. Okay, so the problem description is being given, and the solution for that also should be specified, how it should be done. So some templates are going to be given so that it should be used for the application. The consequences of those things means whether the proper results that will be going to get or not, some trade-offs will be there. Okay, so depends upon the application, the different solutions that will be going to get from the design patterns. For example, in that calculator is there. The calculator, you'll be going to have different types of calculator. Business calculator is going to be different. Scientific calculator is going to be different. Okay. So when these things are going to be used, so application is one, but design description is going to be different. Okay. You can observe the pattern like this. Name is an observer. It is nothing but a function. Function name it is going to be. The description of the problem definition, it is going to be what this particular object is going to do. So displays the object status of the thing and object itself. Okay, there's a name of that observer, or we can say that the class. That is, then problem description, what this particular function should do, that should be specified. Solution to that also should be specified. Okay, and the consequences on that, whether the input is correct or not, output is going to be proper or not, those things, when the input is going to be given to the system, whether it should perform properly. Okay, so whether it is performing or not properly, those things are going to be the consequences of that. Based on the input, the consequences are going to be present. The way in which you are going to see the observer is going to be different. Now you see the multiple displays using the observer pattern. Now I am going to observe for the subjects. Okay, ABCD, there are 4 subjects are there, and the marks are being displayed here. Observer 1 is going to observe that in the pie chart. The observer 2 observes those things in the bar chart. Both are different. The way in which that we are going to see the functionalities are going to be different. Here is the functions of that observer pattern of the UML model. Okay, for all zeros in the observers. Okay, update it. Then return the subject status. then here observer will be there, update, he has to update it, observer status that he has to update. So functions are going to be there in this. Okay, so you'll be going to use generality, then you can have aggregation. Okay, those things that you'll be going to have it. So based on the inputs that it is going to be considered for this, whether it should completely should be inherited or partially it should be inherited, those things are going to be left to the individual programs. That's how many problems are also going to exist in the case of design. So if you are not going to write properly the design cases, then the associated application or associated programs are going to be act differently. So first of all, you should tell the several objects, the state of that is going to be changed when the observer is going to be, observer patterns are going to be there, means the way in which that issue should be looked, that it is going to change. So if it changes, the data is going to change again. And there is another pattern that is called as a facade pattern. Okay. So here it is, the interfaces are going to be there in this, the related objects are how it is getting communicated, incrementally how it is getting developed, that it is being shown in that facade pattern. Then iterative pattern, step by step the information is getting collected from the elements and it should be get implemented in that. Okay. Then another is decorative pattern, UI application. Okay, how that it runs, functionality how it that runs, so that it is going to be seen in this. All these things it works only with the application, which application that they are going to use, whether that supports or not depends upon that. The design problems are going to be there in that.